Hello, John. My name is Zekeria Mohamed. I am studying for Brinjura team. I need to share with you my homework. So I will start my homework. This is what I want to solution. The first question was. This is the first question. A unity feedback control system with the following open loop transfer function is a. I want to solve this one. So the first one is so the first one is I will delay this one. The first one is G S H S is equal. This is the first one. K S plus 2 and S plus 4. This is the first equation. So this is the first equation. We will solve this one. So how gonna we solve? First time we will start K. So we will say 1 plus K S S plus 2 and S plus 4. This is the equation. So this one is 0. We're gonna use this on 0. And right now we're gonna say this K we will remove on the other side. So we say like S S plus 2 and S plus 4. So we say plus K. The K one we will remove here. So we say 0. So right now S and S it will be S cube plus 6S square plus K is equal 0. Is equal 0. Right now, like we need root looks, like we need open the number of polys and number of zeros. So number of polys, it will be number of polys, it will be number of polys, it will be like 0 minus 2 and minus 4. So the number of zero number of zero number of zeros, if it will be none. So right now we will produce all starting with those polys and going to infinity. Right now we have to show like the point of real axis and the locus of number, like real poles zeros and number of poles and number of zeros. So we have to show the S plane here. S plane S plane So as plane, we have to draw like this. We have to draw like this. Here is 0. Always here is 0. And we have here -2. And also here -4. And also here is like we have how many balls we have? 3. 0, -2, and -4. So here is infinite. Here is infinite. Here is infinite. Here is infinite. So how many balls we have here? 2. Also this one. So right now we have to we have to find centroid number of asymptotes. Like we have to say number of asymptotes, how much? Asymptotes. It is 3. So centroid like here balls and zeros over over 3. So right now we have to find asymptotes of angles. So how we gonna find like this, like 2q plus 1 and 180 degree over 3. So we're gonna change always the one place. Like we have to use like 0, 1, and 2. So here is like 60 degree, I guess so. Or we gonna calculate like open bracket 2q times 1. Yeah, it is correct. So we got 60 degree. We got 60 degree. We also said like same 100. Like we also same like 2q 2q plus 2 not 2q here is 0 also here is like 2q plus 0 is equal 180 degree. 180 degree. The other one is 60 degree. The other one is also 180. So it is 300 degree. So right now we have to find from the characteristic equation. For example, like k is equal minus s plus 2 and s plus 4. So this one we have to use this formula d over ds minus s plus 2 s plus 4 is equal 0. So this one is 3s square plus 12 square, not square, plus 12 plus 8 is equal. So here is s minus 2 plus or minus 2 radical 3 over 3. So right now we find like this one, we find minus 0.8453. So we have to go back this one. So here it is like here minus 0.8 something like that. Also the other one, for example, the other one also like 16 radical 3 over 9 is equal 3.0792, something like that. Like also here like something like that. So right now we have to use stability. The stability one like s cube plus 6 square plus 8s plus k is equal 0. So we have to say like s cube, s square, s1, s0. Like here is 1, also here is 6, also here is 8, also here is k. So c is multiplied 8, k multiply 1, something like that. So it will be 48 minus k over 6. And here is also 0 because we don't have another number to multiply. So a zero is k. A0 is k. A0 is k. So this one we have to say this one is this stable. This one is stable. So So we have to we have to we have to show this one. We have to show the MATLAB. So this is the code. I want to if it is I want to see if it is correct or if it is working. I will wait a little bit. I will I will look if it is working. It is just keep going. We will see if it is running out the code. So so this is the answer. We don't have any problem. So we don't have any problem about the code, I guess. We don't have any problem about the code. So right now we gonna move the the other question. We're gonna move the other question. So what is the other question? The other question, the second question, is there are three op-amps connected to the cascade in a control system. The waveforms are as shown on the side according this. So first one is like draw the appropriate connections and find the parameter values used. The other one, the B1, is if the op-amps used in the circuit are connected in parallel and pass through the collector with a gain of one obtained in the transfer function and interpret what the circuit is. So we're gonna try to solve the second question like this. So the second question is this is the second question. So the second question is we say V1 is equal minus R F1 over R I N1. This is Vn. So Vn we say 1 and minus 0.5. So minus Rf1 over Rin is minus 0.5 and Rf1 over Rin1 it's gonna 0.5. So Rin1 it is 20 k ohm and RF1 it is 10k ohm. So stage 2 second op interverting interrogator. So Vs V2 V2s minus 1 over R2 C2s. This is V1s. So dV square over dt. So it is minus 1 over R2 C2. So here it's 0.5 over R2 C2. R2 C2. Sorry, Jam, I don't have any mouse, so I'm using my hand. So a little bit the right what I'm writing, it's a little bit is it is it's making so hard. So that is so right now 1 VS we have to say 0.5 over R2 R2 C2. It is 1 here, and R2 it is R2 it is also R2 and C2 it is 0.5 S. So R2 it's gonna be use K ohm 100 K ohm. C2 and C2 is 5 K ohm, 5 metro F. So that is it. We will see if like we say V out over V in. So G1 S plus G2 S G1 S plus G2 S plus G3 S. So G1 S it is means 0.5. R2 and C2 it is 0.5 also. G2 minus 1 over 0.5 S. So it is minus 2 over S. R3 C3 it is 1. So we say V out over V in S it is 0. Minus 0.5 minus 0.5 minus 0.5 minus 2 over S minus S. So for example KB it is 0.5 Ki and minus 2 K0, this one. So right now we're gonna see the code if it is working. Let us see. We will run out and we will wait again until he's broken. So right now we don't have we don't have any problem about here. Everything is correct. Everything is correct. So so we're gonna go the third equation. What's the third equation? The third equation is for a cruise control system, the vehicle the vehicle speed dynamics are modeled with the following characteristics equation: s cube plus 4s square plus 5 plus 5 open bracket 5 plus k s plus 2 is equal to 0. So we're gonna calculate this one. So we have to say s cube s square s1 and s0. So 1 1 4 5 plus k 2. So 4 times 5 plus k, it is 4 5 plus k, 2 times minus 1 minus 2, and the other one is 0. So here is 4 and s0 is 2. S0 is 2. So the final step is like here, like this. So right now the k is equal minus 4.5. So it is like the positive feedback gain. So the positive feedback only the vertical stable ranges like this. So right now we gonna calculate the fourth equation. The fourth equation is the open loop transfer function of unity feedback control system is given below, like gs times 10 over s open bracket s plus 5, like that. Like for example, interpretation cruise control meaning, like for example, overshoot jerk, aggressive throttle brake, correction is speed overshoots the step point and feels jerky, something like that. So we're gonna calculate that one. We're gonna calculate that one. Step one, step steady state. Step steady state. Step steady state is 0. So for example, KV limit SG S, so S is equal 0, and limit s s here is 0 also, so times 10, this is the equation. S plus 5 is equal, it's gonna be 10 over 5. Here is 2, so 1 is equal 1 over k, v is equal 1 over 2 is equal 0.5, is equal 0.5. So closed loop transfer function and characteristics equation, closed loop TF and TS is like GS 1 plus GS. So we have to say, for example, like 10 over S plus 5 over 1 plus 10 over S plus 5. So right now we have to say like 10 over S plus 5 plus 10 is equal 10 over S square plus 5 S plus 10 S plus 10. So the characteristics equation is S square plus 5S plus 10 is equal 0, is equal 0. So like for example, we will compare with the standard second order form. So S square plus 2 omega th omega th like plus S plus omega square is equal 0. So right now like 10 omega radical 10, it is 3, it is 3.162, and the other one 5 over 2 over 2 radical 10 is equal 0.7906. So like we have to say MB C C like pi over 1 2. So MB is 0.0173, and it is like it's like 1.73 percentage. So TR is 1.8 over WN, like omega n, 1.8 over 3.162. So T is 0.569 S. So TS is 4 over WN omega n. So it's like 5 over 2, 2.5, like that, something like that. Or you can say like TS is 4 over 2.5. For example, 1.6 is something like that. So we have to check this one also, the code. This is the code also. We have to run also this one. We will wait until it's working. It is working. So we don't have also this one. We don't have any problem about this. So this is my homework, teacher, and I hope I did my I did what I can. So I hope I will get a good point to jump. See you. Take care.